Alright guys, I'll just give a quick glimpse on binary search tree. Again, it's very simple. It's a special case of binary tree, you can say, but it's another separate type, okay? Another separate type of tree, but it's again a special case of binary tree, okay? Here also you should have at most two children only. Each node should have at most two children, each node, okay? Right. But the speciality of binary search tree is, I'll tell you what. Okay. We put numbers like this. Mhm. 50 greater 56, 81, right? Okay, so yeah, this is a binary search tree. Can you get something from this? I would, highly recommend you to pause the video and infer something from this tree. Of course, this is a binary tree, but there is something special about it. Okay, that makes it binary search tree. Can you get what it is? Okay, just pause the video and think about this. I think this number is not clear. This is 56. Okay, just think about the this tree. Pause the video. I hope you got it right. So here, if you see that, if you see this tree closely, you have this root, okay, root node for this whole tree, right? Again, for this subtree, this is the root. For this subtree, this is the root. For this subtree, this is the root. You know that, right? If you closely watch all the root elements of all the subtrees, okay, if you closely watch those, the uh, sorry, wait a minute, the elements, the nodes which are left to the, which are in the left of the, which are in the left of the root node are smaller than the root node, and again the elements which are in the right of the root node are greater than the root node. Okay, if this is true, then this is called as a binary search tree, BST, binary search tree. Again, if you follow this subtree, again if you follow that subtree, the elements which are in the left of the root node is 15 here. So elements which are in the left of the root node are smaller, and right of the root node are greater or larger. Okay, this is same for this case, this one also. So that condition, the elements which are in the left of the root node should be smaller and the right of the root node should be greater. That condition should be satisfied for each subtree. Okay, then only it is called as a binary search tree, each subtree, right? Okay, super. And here also you can follow the concept of traversals. Okay, here also you have three types of traversals: pre-order, post order, of course, and in order. We can follow the same. Okay, but I think I have to tell you about tell something about in order. It's something special. I'll tell you why. It's something special. We'll take the same example. Okay, mm, I'll do the in order alone because it's something special for this binary search tree. So in order for binary search tree, right? I'll take another example, say 85. Something smaller should be put here, so 56 maybe. Here I could put 90. I'll put 190. It's very larger, right? So, and here I can put 35. Here I can put 77, and here I can put 17, and here I can put 37. Here I can put 74, and here I can put 81. Here I could have 92. Here I could have 150, right? So this is a binary search tree. Okay, ignore if there aren't any mistakes, but this is the binary search tree, right? So check whether it works. So you can see if you check each subtree, the left of the subtree should be smaller than greater than that. Check all the subtrees, right? Okay, super. So with this condition, let's do the in order. There is something special about it. That's why I'm doing in order alone. Okay, you can always do pre-order or post-order. That's very simple. Wait a minute. So how do you do in order? You follow LPR, right? First you go for left one. In that, first you have to visit the left subtree only. So we again visit the left one. Again you have to visit the left one only. So 1, 2, 3. So that's LPR, right? PR. That's why it's called as LPR, right? LPR. Okay, fine. Then go for, yeah, visit the left subtree. So go for the right primary. I mean the parent or root node of this subtree, whole subtree. Then here again you have to do 5, 6, 7 LPR only, right? Left, then root node, then right. So you have 8, and here also you have to follow the same 9, 10, 11. Now write the order, right? I hope you understood this. 17, 35, 37, 56, 74, 77, 81, 85, 92, 150. Here I did a mistake. I just put a 150, which is lesser than 190. So I have to put 220. Okay, I have to put a long number. So 190, 220, right? Okay. Pause the video and observe this, right? Could you get something from this? Just pause the video and observe this. I hope you got something from this, and this is in ascending order, right? Ascending order. Superb, right? When you do in order traversal for a binary search tree, you will get the order, you'll get the elements in the ascending order, right? You can see 17, 35, 37, 56, 74. It goes in the increasing order. So the key takeaway here is, when you do in order traversal for binary search tree, you will get the elements are in increasing order. You will see the elements which are in increasing order, right? And that is something which is important from this binary search tree. This may be asked in some competitive examinations also. Okay, thanks a lot.